So the next thing that we're going to do is a live demonstration of how to acquire an EFTEM spectrum image. So I'm currently in the EFTEM map technique, and this is the wrong technique for EFTEM spectrum imaging. So let's hit the home button, and then EFTEM spectrum imaging is in its own technique called EFTEM SI. So we'll enter the EFTEM SI technique. And we have some common palettes with EFTEM maps. So we have the camera view, and we have filter state, and EFTEM SI. So I'm pretty much set up as we left this microscope after the mapping lecture. So we're looking at the same area of the semiconductor device, and everything's not changed. So well, let's just do a quick so we're going to just acquire a quick EFTEM spectrum image. The first thing that we have to do is go into the setup, and then you have this palette here. So there's some remnant kind of settings here from a previous experiment. So we have some edges in this list. I want to clear this all out. So I hit the little cross button that allows you to erase entries from this list. So we'll start off with the energy range section here. So I'm interested in nitrogen and oxygen. So we can use the periodic table, and we can say, I want to have nitrogen and oxygen. Okay, and then that's now, those elements are now in my list. A neat little button here right at the bottom left, we have this one that says scale energy range to edges. So if I scale energy range to edges, essentially that adjusts this range here so that it fits both the nitrogen and the oxygen K edges in the range. So if you're not sure what range you need, filling this kind of elemental list using the periodic table is a good start position. We could also say, actually, that's a little bit too much. Let's go actually instead from 350 to 618. So once we've determined our range that we want, the next thing is to determine the step size and the slit width. So we can generally, either we want the slit width and the step size to be the same, or we want the step size to be less than the slit width. So that's going to mean that we're oversampling, which actually with the continuum camera tends to give really good results. So I tend to usually pick a step size when I'm doing EFTEM SI on a continuum that's half the slit width, and the slit width is going to determine the energy resolution in the data set. So let's keep these parameters of 7 EV, or maybe not. I'm going to go up a little higher. So I'm going to go for a 12 EV slit and a 6 EV step. And let's stick with binning 4 there. So yeah, then we need to define the detector conditions or parameters. So again, it's always binning and exposure time. So we'll stick with binning 4, and I'm going to put the exposure time, say 3 seconds. Then at the bottom, it's telling us the total integration time. These options here are really important. So we always want to go high to low. You always want to have the weakest intensity feature captured first to avoid afterglow on the detector. And this aligns ELP before acquire. Generally, we don't want that to be checked because we don't want to expose the sensor to high brightness before capturing much fainter signals. So I'm going to hit OK. And then one thing to always remember when you do EFTEM spectrum imaging is that when you hit OK in that dialog, it doesn't then start acquiring the data. So we need to go back to the palette, hit capture, and off it goes. So this is a spectrum image object, so it's a data cube, and we have X and Y spatial coordinates and energy loss, and then there's already a predefined picker region here, and then this is the spectral data that's extracted from this picker region. So obviously there's lots of slices missing from this cube at the moment, but those slices are getting kind of filled in sequentially. So we're kind of acquiring filtered image after filtered image after filtered image. It gets put in this data cube, and that's why we see this kind of this spectrum growing in reverse. So we kind of having the high energy loss slices acquired first, and then kind of decreasing. So you can already see kind of features of the oxygen edge. And then let's see what happens as we get up to the nitrogen K energy. So yeah, we don't have as much nitride as we do oxide, but you can see that if I change the picker region, you can see the nitrogen K edge there. So yeah, EFTEM spectrum imaging is pretty neat. You end up with a data set that's kind of much more like a spectroscopy data set. So we can use the picker tool. The advantage here, if we want to do any mapping, is that we can define or decide our mapping parameters, so our windows, like after the fact. So actually it looks like my energy has drifted a bit, but I'm going to make an oxygen map. So we can control left click and drag. And then I'm going to use this feature called map signal dynamic, which I think we cover more in the spectrum imaging module. But if we right click map signal dynamic, then I have oxygen map. And then I'm going to use Control C, Control Alt V. And I'm going to move the window over to nitrogen, and you can kind of see how then I have my nitrogen map. So that's really the basics of EFTEM spectrum imaging. So I'll leave it there and we can move on to the next lesson.